Hey everyone, welcome back to Astronomy Daily. I'm Anna.
And I'm Avery. It's Tuesday, August 18th, Series 5, Episode 170.
And we've got a genuinely satisfying one to lead with today. After 3 weeks of will they, won't they, SpaceX has actually pulled its Starship upper stage out of the Indian Ocean.
Ship 40 makes it home, closing the loop on a story we've been checking in on since it splashed down back on July 24th.
Then 3 more. A dead star in a nearby nebula that's basically showing us our own sun's obituary 5 billion years early. New evidence that the Milky Way itself was built out of a galaxy we crashed into almost 12 billion years ago, and China bouncing back fast from a rocket explosion with 2 launches in about 23 hours.
Plus, a quick one for anyone stepping outside tonight. There's a nice pairing in the western sky right after sunset.
Lots to get through. Let's get into it.
Okay, so let's actually finish this story. Anna, take us back to the start because it's been a genuine saga.
It has. This goes back to July 24th and Starship's Flight 13. The upper stage, Ship 40, did something no Starship upper stage had ever managed before. It flipped, reignited 2 engines, oriented itself, and made a controlled soft splashdown in the Indian Ocean off Western Australia, completely intact.
Which nobody was really planning for. Usually these things topple over and break apart on impact.
Right, that was the original good news story. SpaceX got an intact upper stage sitting on the water and decided that was too good an opportunity to just scuttle it. They sent recovery vessels out, the Normand Ranger, the Go Australis, a ship called Skimmer Tide, and started trying to lasso a 170-foot stainless steel rocket that had drifted more than 400 kilometers from where it landed.
And that's when it got complicated.
Very complicated. The tow back toward shore started in early August, but the seas didn't cooperate. Conditions kept deteriorating. The convoy could only creep along at 1 to 3 knots. And on August 8th, Elon Musk gave us the line we led an episode with a couple of weeks ago: ship recovery is not looking good right now.
And prediction markets had it down around an 18% chance of actually making it to shore.
That's right where it sat for a while. But here's the actual news today. It worked. Over the past few days, the Normand Ranger's convoy got Ship 40 secured, built up speed, and towed it all the way in toward Dampier in Western Australia. As of this week, SpaceX has recovered the ship.
3 weeks adrift, and they actually brought it home.
3 weeks, more than 400 kilometers of drift, rough seas that nearly sank the whole recovery effort, and an intact 170-foot Starship upper stage sitting on a dock instead of on the seafloor. That's a first.
What do they actually get out of having the physical vehicle back versus just the imagery they'd already collected?
That's the interesting part. SpaceX had already said the mission's main objective was done regardless of outcome, because they got close-up satellite and drone imagery of the heat shield and engine sections while Ship 40 was still floating. That inspection showed the thermal protection system mostly held up despite higher than expected aerodynamic pressure during ascent, though there was some tile loss and damage around the aft trim that happened earlier in flight.
So having the actual hardware back is a bonus on top of an already successful data run.
Exactly. Now, engineers can do hands-on forensic inspection instead of just working from photos, which is a much richer way to validate what held up and what didn't for the next generation of ships.
And the program hasn't exactly been standing still waiting for this to resolve.
Not even slightly. Ship 41 has already been through cryogenic testing and engine installation, and it's expected to roll out to the Massey's test site for static fire testing as early as this week. Booster 21's finished its own cryo campaign and is having engines installed for its static fire. And Flight 14, the next full test flight, is currently targeting around August 20th, so just a couple of days from now.
So this whole saga wraps up almost exactly as the next chapter is about to start.
Which is very on brand for this program at the moment. There's basically no gap between close one story and open the next one. But Gregor has also been busy in the background. SpaceX ran 22 separate Raptor 3 engine firings there over the last 2 weeks, including one that ran a full 140 seconds, matching a complete ascent burn.
That's a lot of engines getting put through their paces for a rocket that's supposedly still in a testing phase.
It's the clearest sign yet that they're trying to get the cadence up. Anyway, Ship 40's home. After 3 weeks of is it lost at sea? It isn't. Good outcome, and one less loose thread for us to keep tracking.
We can finally stop saying still unresolved about this one.
Next story is a bit more melancholy, but in a genuinely beautiful way. Astronomers have gotten the clearest look yet at what happens to a star like our sun after it dies.
And we're talking about the sun's actual eventual fate here, not a metaphor.
Not a metaphor at all. This comes from the Helix Nebula, about 650 light-years away in the constellation Aquarius, one of the closest and most photographed planetary nebulae there is. At its center sits a white dwarf, the dense leftover core of a sun-like star that ran out of hydrogen fuel, ballooned into a red giant, and then shed its outer layers into space.
Which 5 billion years from now is exactly what's going to happen to our sun.
Precisely. This is our own star's future, just further along the timeline. A team led by Peter Van Dokkum at Yale, along with Roberto Abraham at the University of Toronto, and Imad Pasha at the Dragonfly Focused Research Organization, studied the nebula's outer faint halo and found something nobody directly resolved before: 22 distinct arc-shaped structures called bow shocks. Essentially wakes left behind as clumps of the dead star's ejected material plow through the surrounding interstellar gas.
So we're watching the star's old outer layers actually being absorbed back into the galaxy.
That's the headline. This is the first direct observation of stellar debris being broken apart and returned to the interstellar medium in real time. Van Dokkum put it simply: we are seeing material shed near the end of a star's life being broken apart and returned to the galaxy.
How long does that process actually take?
Relatively fast on cosmic timescales. The researchers estimate those clumps survive for around 10,000 years before they fully disperse and blend into the surrounding gas. The nebula's outer ring itself spans about 5.7 light years.
So this is basically recycling. The star's guts eventually become raw material for the next generation of stars and planets.
That's exactly the point. Every heavy element in your body that isn't hydrogen or helium came from a star that did this at some point. Watching it happen in real time, even in a nebula that's already thousands of years into the process, is about as close as we get to watching that recycling loop in action. The results were published August 12th in Nature.
A nice one to sit with. Not a disaster story, just the actual shape of how stars end.
And a preview of a very, very distant Tuesday, 5 billion years from now.
Story 3, and this one's about our home galaxy's own deep history.
Right. New research using Hubble, backed up by data from ESA's Gaia mission, has identified a previously unknown collision that helped shape the Milky Way almost 11 billion years ago.
Previously unknown is doing some work there. How do you find a collision that happened that long ago?
You look at the fossil record it left behind, specifically globular clusters, these dense balls of hundreds of thousands of old stars that orbit the galaxy. A team led by Davide Massari at Bologna's Astrophysics and Space Science Observatory, with Chiara Zerbinati from the University of Bologna doing key analysis of the Hubble and Gaia data, found a distinct population of globular clusters that didn't match any previously known building block of the Milky Way.
So a whole separate family of star clusters just hiding in plain sight.
Hiding in plain sight for decades, basically, because until you have precise enough motion and composition data, one old globular cluster looks a lot like another. This third population traces back to a dwarf galaxy the team's calling LKH for Low Energy Kraken Heracles, which merged with the Milky Way about 11.8 billion years ago, just roughly 2 billion years after the Big Bang.
How big was this thing, relatively speaking?
Modest by galaxy standards, around 500 million solar masses, but it brought its own globular clusters along with it, which merged into the Milky Way's own population, and the collision likely triggered bursts of star formation and contributed meaningfully to our galaxy's early chemical makeup.
And this is a different event from the Gaia, Sausage, and Enceladus merger, the one we've mentioned before as the Milky Way's biggest ancient collision.
Different and earlier. LKH predates that Gaia-Sausage Enceladus merger by about 1.8 billion years. So this pushes the known history of the Milky Way's construction by collision back even further than we'd already mapped.
It's a good reminder that the Milky Way isn't really one continuous thing. It's more like a scrapbook of everything it swallowed.
Which is exactly the sentiment Massari captured. He said, "Our home is the Milky Way galaxy, but we do not know how our house was built. This is one more floorboard in that house getting identified." The findings were published August 18th in Nature Astronomy.
Somewhere between the LKH merger and Gaia-Sausage Enceladus, our galaxy basically had two formative growth spurts back to back.
And there's likely more of these still hiding in the data. This is very much an ongoing excavation. Okay, on to our last story today, and a quicker one. China's space program had a rough moment last week and a strong recovery this week.
Set the scene. What happened?
On August 10th, a Long March 7A rocket failed about 85 seconds into flight. The fairing and upper section of the vehicle bent backward and broke apart, destroying the rocket along with its payload, a communications satellite called Zhongshan 4B. The cause is still under investigation.
Which is obviously a serious loss, both a rocket and a comm satellite gone.
It is, and there was a real question of how quickly China's program could get back to flying after that kind of very public failure. The answer turned out to be fast. On August 16th, they launched twice within about 23 hours using two completely different rockets from two different sites.
Walk us through both.
First up was a Long March 12 from the Wenshang Commercial Space Launch Site, carrying 24 internet satellites into low Earth orbit. That's the Long March 12's seventh consecutive successful mission since it debuted in 2024. Then, about 23 hours later, a Long March 2C lifted off from the Taiwan Satellite Launch Center, roughly 1,300 miles to the north, carrying a satellite for the United Arab Emirates.
And the 2C is the old reliable of the fleet, right?
By a wide margin. That airframe's been flying since 1982. So the message China's sending here is pretty deliberate. Newer commercial rocket, decades-old workhorse rocket, two different launch sites back-to-back less than a week after a very public failure.
A calculated show of operational depth rather than just, look, we launched something.
That's exactly the read on it, proving the failure was contained to that one rocket and one pad, not a symptom of something systemic across the program.
A quick one before we go. If you step outside after sunset tonight, look low in the western sky.
The waxing crescent moon, just a few days old, is keeping company with Venus tonight, and Venus is blazing away at magnitude -4.1, so it's genuinely hard to miss about 45 minutes after sunset.
An easy, no telescope required one for tonight.
Okay, that's today's episode. Starship's Ship 40 finally makes it home after 3 weeks adrift. A dead star showing us our sun's own distant future, new evidence the Milky Way was built out of an ancient galactic collision, and China's fast recovery with back-to-back launches.
Plus tonight's Moon and Venus pairing if you get a clear sky.
If you enjoyed today's episode, the best thing you can do for us is leave a rating or review wherever you're listening, and share it with a fellow space nerd. Full show notes, sources, and links for every story we covered today are at astronomydaily.io. And you can find us on social media. We're at Astro Daily Pod pretty much everywhere.
We'll be back tomorrow with more from the world of space and astronomy. Until then, keep looking up.
See you then. Clear skies, everyone.
Astronomy.